Hello students, myself Dr. Anupreeta Mishra and you are watching Anupreeta Mishra's Electrical Engineering. This particular channel I have started to clear up all the electrical doubts of the students from scratch to the height of concepts actually. At what level those concepts should be understood by the students to pursue the electrical engineering. My channel would be helpful to all the electrical engineers who are studying yet or doing their PG or preparing for any exam or interview, technical interview, or even they are going with their professional life also. There also these particular videos would be helpful to them. Uh, right now I am going with the synchronous generator, that is known as the alternator, and prior to this particular knowledge of sharing what I am doing today, prior to that I have published two videos related to the alternator. One was nothing but the brief explanation of the alternator. There I explained the simplest working principle of alternator. Though I didn't loaded the generator or the alternator, that was a simplest explanation how EMF is being induced across the three-phase armature winding. Later I have taken up or I have explained the reason why three-phase armature winding is provided over the stator. That means we have to make it stationary one and not the rotatory one to be provided over the rotor. We keep it always over the stationary stator in large alternators whose capacity to generate power is in megavolt ampere or somewhat like that. Means those alternators which are being used for the generation of the power, everywhere we have to think of placing armature winding, three-phase armature winding over the stator itself. Now today I am giving you the relation between the speed and the frequency. Now you will ask, what is which speed? That speed which is being given by the turbine to the rotor, because turbine and the rotor are connected with the same shaft. So as the turbine moves because of the pressure of the steam or the water, so that will turn the rotor with the help of this shaft. So rotor turns. Say rotor is turning in the clockwise direction. This direction I will take, taking it up for the next explanation later. Frequency. Frequency is nothing but the frequency of induced EMF across the three-phase armature winding. So I want to build a relation between rotation speed of the rotor given by the turbine and the frequency of that EMF which is being induced across the three-phase armature winding, stationary armature winding. Now here number of poles have spatial impact on this particular relation or this derivation. Now one thing I want to explain you here, that here the speed we are providing to the rotor, speed is not at all going to be generated by the system by itself. No, that is not an automatic one. Speed is we provide through the turbine according to our choice, and the induced EMF would have the frequency, AC EMF would have the frequency according to this speed and number of poles existing over the rotor. That means frequency is being, or frequency is the development due to number of poles and due to the rotation of those poles. So I would be creating a definite relationship between or amongst speed given to the rotor by the turbine, number of poles which is being the according to the design, the number of poles are being developed over the rotor, and frequency of the induced EMF. So I would be explaining you the derivation about a relation amongst these three actually. So let's start that. Say N, capital N is nothing but the revolutionary speed of the rotor provided by the turbine to the rotor in RPM, that is revolutions per minute is capital M. This is nothing but the revolutionary speed of the rotor in RPM. P, capital P is the number of poles, and certainly these number of poles can be associated with pair of poles. Number of pair of poles into twice. We have to either take care of total number of poles or total number of pair of poles. So pair of poles into twice gives you the number of poles. So small p is the pair of poles number and capital P is the number of poles altogether. If we have two poles machine, so it would be having one pair of pole. If we have four pole machine, or 4 pole alternator, that means it would be having 2 pair of poles that way. This frequency is nothing but of induced EMF actually. So prior to explaining you all these things, I want to explain you something related how EMF is being induced in individual armature conductor placed over the inner periphery of the stator. This is the inner periphery of the stator. Here the slots are being cut. There we are keeping the conductors in these slots throughout the periphery, and that connection of those conductor is in 3 phase, as I said earlier. Amongst all those conductors of armature winding, I am considering right now only one conductor placed in this slot, and the position of slot or the position of conductor I am taking right now just under the impact of north pole. Now here, as soon as the rotation of the rotor starts due to the turbine turning, so all these conductors like A conductor will be under the impact of variation of flux, because one by one in alteration north pole, south pole are cutting that conductor or all those conductors which are existing in the periphery of the stator. So naturally rate of change of flux is there. So that rate of change of flux will produce EMF according to Faraday's law in all the conductors. As I said earlier, I am taking only one conductor right now for explaining how the EMF is being changing its direction from positive to negative, positive to negative, positive to negative likewise. So I just want to judge over here, due to the rotation of whatever number of poles are there, how many cycles of the EMF are being induced in one revolution of the rotor. In one revolution of the rotor, in one conductor, how many cycles of EMF are being induced in a conductor, and certainly that will be assisting me to find out the frequency of EMF. So that is there. So the quantity of EMF which is being induced in conductors is nothing but depending on the how strong or strengthened or strong field is impacting conductors. If the strength of the magnetic field is weak, so the EMF induced would be of lesser amount. If strength of the poles are strong, so magnitude of EMF induced in these conductor will be of larger magnitude that way. But number of cycles to be produced with a single revolution of these poles is nothing but that I want to check over here. That frequency I want to know. But this is what I said right now, quantity of EMF, magnitude of EMF. But what would be the direction of EMF? Direction of EMF is going to be judged by Fleming's right-hand rule. Fleming's right-hand rule says that thumb is indicating towards the direction of motion of the conductor for which we want to know the induced EMF. Index finger is giving me the direction of magnetic field, and middle finger is giving me the is along the length of the conductor, and also it is providing me the direction of EMF. For this purpose, the conductor in which I want to know the EMF, that conductor should be under movement. Mind my words, that the conductor for which I want to know the direction of EMF, that conductor should possess velocity. What is here? This conductor is not possessing velocity because it is over the stator. It is not rotating. What thing is rotating? Rotor is rotating, or the magnetic field is rotating. So what should I do here? What kind of perception I should follow here? So I am imagining as if over this north pole an observer is standing like a dot. This dot is nothing but observer at north pole that I mentioned here. This observer is rotating along with the rotor, so it is rotating in clockwise. And if observer I am feeling that, or if I am assuming that, or observer itself can assume that he is stationary, so with respect to observer, conductor is understood or seems that it is rotating in anti-clockwise direction. So this way I am finding out the direction of movement of the conductor with respect to this observer in the anti-clockwise direction. And why I did so? Because this is the A conductor in which I want to know the induced EMF's direction. So this conductor's movement must be considered to apply the Fleming's right hand rule, not any other object. So my conductor in which I am finding out the direction of EMF, that conductor has to be moving with respect to some relative point. So my relative point is lying over, or the observer is lying over the north pole, though that observer itself is rotating in clockwise direction, but it seems that to that observer that conductor is rotating in the anti-clockwise direction. So with respect to this observer, conductor is rotating in anti-clockwise direction. So this I am showing you the direction of the rotation of the conductor. Here I am mentioning direction of conductor. This is the conductor's directional rotation. Now, I will apply all the three things here. Direction of conductor, so it is moving in this direction. This is showing the direction of the magnetic field. So as this is north pole, so flux is emerge out of from it. So going or cutting the conductor in vertical direction. So my these two directions are fixed. And according to Fleming's law, these two are in perpendicular direction and all the three are mutually perpendicular direction. So this finger is getting inside the board. So direction of EMF would be perpendicular to the board and inside to the board. So direction of EMF will be inside to this conductor. Why so? Because direction of magnetic field is this one, direction of movement of the conductor is this one. So EMF's direction is inside. When conductor moves like this, because I am assuming conductor is moving. So when conductor is moving here, so that time it won't be under the impact of any pole, because this is nothing but the neutral axis exactly in between the two poles. Now when conductor get into the impact of south pole and as it comes over here, a conductor, so it would be under the impact of opposite direction of magnetic field. Direction of motion according to anti-clockwise would be downward. So I will keep my thumb downward. Direction of magnetic field is inside the south pole, because direction of the flux will be going inside the south pole. So this is the direction of field. So the direction of EMF would be like this. So when the conductor was under the impact of north pole, so the EMF direction is perpendicular to the board and inside to the board. And when conductor comes here under the impact of south pole, so the EMF direction is outward and perpendicular to the board. That means direction of EMF changes. So this creates the frequency of variation actually. So remaining part I will be telling you this way, that as the conductor is under the impact of north pole and say its induced EMF which is perpendicular to the board and inside to the board, I am considering as the positive one. So this is nothing but the positive induced EMF in conductor A when it is under the impact of N1 north pole. When it comes at this position at the neutral axis, so it would be having zero EMF. When after next 45 degrees, here actually 45 degrees moment is nothing but there is an angle difference between two poles has 90 degrees. So as it further moves by 45 degree, so it would be having exactly opposite direction of EMF, means say negative EMF. So and that would be the maximum one. So when it would be under the impact of north pole, it would be having positive maximum EMF. When it is under the impact of south pole, it would be having maximum negative EMF. Again it will come over here over the neutral axis, which is being hidden here back to the shaft actually. So that is again having the zero EMF. Then after this, as conductor moves from here to here, so it would be coming under impact of north pole and that impact is increasing. So when it reaches over here conductor, it is under the impact of N2 pole. So that N2 pole will again create the positive maximum. So this is the complete cycle of EMF when it goes around by 180 degree. Further, when it goes from N2 to S1, again it would be having variation from positive EMF to maximum negative EMF, and then from S1 to N1, so again it would be having minus maximum EMF to maximum positive EMF. So such we have the two cycles of rotation because of the passing of the conductor through all the four poles. What does this creates the connection? It creates the connection that if we have four number of poles, that means how many pair of poles are there? Two. So we would be having two cycles of EMF for a single revolution. If it would have been six number of poles, so we would have been generated three cycles of EMF in one revolution. That means pair of poles, whatsoever number of pair of poles are there, those many number of EMF cycles are being induced in one revolution in armature winding. So that particular concept I am grabbing here, number of cycles of EMF in a revolution in a conductor. In one conductor, how many number of cycles are there per revolution? That is nothing but EMF cycles per revolution. I am writing mathematically. So this particular thing is equal to the pair of poles, number of pair of poles. So total number of poles divided by 2, this gives me number of pair of poles. And EMF cycles upon revolution as I maintained it, but numerator I divided by seconds and revolution also I divided by second. So EMF cycle per second means frequency and revolution per cycle means capital N upon 60, because this is given in RPM. So divided by 60 gives me revolutions per second. So frequency upon capital N upon 60 is equal to P by 2. So altogether when I sort out, so frequency is equal to capital N into P upon 120 Hertz, or number of revolution can be written as 120 F by P. That means if we have P number of poles and revolution speed is N, so we will be having the frequency of EMF as F. So in India, we keep on generating the EMF of 50 Hertz. Everywhere in India, the supply is of 50 Hertz frequency voltage. So this must be 50 Hertz. And number of poles are as per the requirement where we want to deploy the alternator for what purpose. Accordingly, the number of poles are being designed. For that particular number of poles, alternator is designed. And also the speed matters. So there we will be providing a certain magnitude of speed to the rotor through the turbine. So this way, whatever a magnitude of the rotation or revolutionary speed we want to provide, that we can change as per our requirement. So if we design two-pole machine, either we can design two-pole alternator, four-pole alternator, six-pole, eight-pole, and there also fixed that we want to generate an EMF of 50 Hertz only. So with this particular formula, I can find out with what rotational speed rotors should be rotated. So if we have two poles machine, so this is 250 Hertz is our requirement, to 120 into 50 divided by 2, it gives me 3000. That means turbine should rotate the rotor by 3000 RPM. Similarly, four-pole alternator should be rotated by 1500 RPM to generate a frequency of 50 Hertz in EMF. Similarly, six poles alternator should be rotated by 1000 RPM. Eight poles alternator should be rotated by 750 RPM. This way, we have the variation of speed as per our requirement. If we want to keep the high speed alternators, because those alternators which are running by steam are always high speed alternators, so there we will be following this particular combination. And the alternators which are rotated by the water, so those are always low speed alternators, so there we can follow either of these, or mostly four-pole combination we achieve over there. And high speed and low speed, that particular concept is also dependent on what is the strength of the rotor. Its mechanical strength also matters over there. All these things I'll be taking up later in the next forthcoming videos, but today I want to explain you the relation between speed of turbine to rotate the rotor with that of the frequency of that EMF which is being induced across the armature winding. So hoping that you people are liking my way of teaching with the easiest language to make you understand everything, and certainly this content would be helpful to all the electrical engineers across the world, along with that Indian students who want to switch or transform themselves from Hindi medium to English medium, so that this particular content will help them also. So please do like my videos, share it with your friends, and kindly ask your friends to subscribe my channel to have the strong concepts of electrical engineering and to go deep into it. Thank you.